All right, guys, so we've been talking about standard form. We've also talked about factor form. We are now going to be speaking about vertex form. So before we get into these problems, I want you to understand what vertex form is all about. So vertex form has this format. Okay, we have an A value, we have our X variable, we have an H value, and because it's a quadratic, we have to have a power of 2. And then we have a K value. Okay? So, what I want to talk about here is what the heck does this stuff do? Okay? So the A value in our graph controls some things about our graph. So what does the A value do in our graph? First thing it does is, just like before, it tells you if it opens up or if it opens down. Okay, so how do I know that? That's because our A value will be negative. If it opens down, okay, we'll have a negative A value. If it opens up, it's a positive A value. All right, so that's the first thing. We saw this in standard form from before. Okay, what else does the A value control? All right, so that's one thing it controls. The next thing the A value controls is it controls how wide or narrow our graph is. Okay? All right, so if our graph or A value without the sign, so that's why I put absolute value here. That means regardless of the sign, whether it's positive or negative, if our A value is bigger than 1, okay? So the bigger than 1 it gets, so 2, 3, 4, the bigger the number means more narrow graph. So the skinnier, so think skinnier. The skinnier our parabola gets, okay? So the bigger the number, the skinnier our parabola gets. All right? If A value, okay, without the sign, is between 0 and 1, so think of like 1/2, 1/4, 0.5, 0.75. So think of fractions or small numbers. Okay? The smaller the number is, the more wide my graph gets. Okay? So it's going to get fatter in this case. All right, so let me kind of draw what I'm talking about now. So if it opens up, we have a parabola that looks like this. If it opens down, parabola looks like this. If your A value is bigger than 1, we have a skinny parabola. The bigger the number, the skinnier we get. If it's between 0 and 1 or smaller the number, the wider my parabola gets. Okay, so that's A value. All right, so H value, what does it control? So before we do H value, the true H value is always the opposite of our equation, which I will show you in a bit. So think opposite sign, okay? So H value, and real quick, I'm going to think opposite sign. Okay, so we're dealing with H value, opposite sign. What does it control? So the H value controls left and right shift. Okay, so think of it this way. Our A value moves our parabola left and right. Okay, and we'll come back and I'll show you specific examples of these. What does our K value do? So our K value is not opposite sign, it's just the original sign. It controls up and down shifts. Okay, so it controls up and down shifts. All right, so in essence, this is basically everything our vertex form does. So let's go ahead and jump into number 3. Okay, so before we do standard form, I want to go ahead and I'm going to graph what we call our original graph. Okay, so this is not your final graph. This is just how all graphs start when we're talking about quadratic. So we'll do it in orange. Okay, all quadratics start here, 0, 0, and then you go over 1, up 1. Over 1 again, up 3. 1, 2, 3. Okay. Over 1 again, up 5. 1, 2, 3, 4, 5. Okay, this is called the 1, 3, 5 pattern. All parabolas have that 1, 3, 5 pattern, the original parabola. And now, because our axis of symmetry, remember our vertex is here, here's our axis of symmetry, we're just going to copy these dots on the other side. So copy, copy, copy. All right, so this is not our final graph. Think of this as like our starting graph. And the A, H, and K change this graph, okay? So let's see what the A, H, and K do. So before we do standard form, let me get rid of this. We'll do standard form in a little bit. So let's label our A, H, and K from our new graph. So this is our original graph. Okay, let me write that in. So the orange is our original. Think of it as your OG, original graph. Okay? And now this is our new graph. Okay? So let's look at the A value. So let's go here. Our A value is going to be in front. Since there's not a number, we know our A value, okay, is 1. Okay, so what does that tell us about our graph? That tells us that since it's positive, our graph is going to open up. Okay, since it's, is it bigger than 1? And the answer is no. Is it less than 1? The answer is no. So that means that our graph that we have here is going to be the same width or look almost the same shape as this because nothing's changing. It didn't get fatter. It didn't get skinnier from the original because our A is equal to 1. Okay, so that's what our A value controls. So basically, if you think about it, A value did nothing. When A is equal to 1, nothing really happens. Nothing really changes from our original graph, okay? Now, let's go to H value. So as I mentioned before, H value, you want to think opposite sign. Our H value is right here. It's always in parentheses, okay? So we want to think of the opposite sign. So this is the H value, but we need to do the true H value, which says our H value is really -5. Okay, so what does that mean? Okay, that controls left and right shift. So that means our original graph is now gonna move left or right. Okay, the only time it doesn't move is if h was a 0. It's not a 0, it's a -5. So that means our graph is gonna move left 5 because it's negative. We're gonna move in the negative direction 5 times. Remember, we had to switch the sign though. So this is your h in the equation, but we want the true h, which means switch the sign. So we're going to move our graph back 5. So, okay, we're going to just move the vertex for now, and we'll do these other dots later. So we're going to move backwards 5 times. 1, 2, 3, 4, 5. Okay, so now this dot has moved backwards 5 times. All right. So now we go to the K value. Here's the K value. It controls up and down shifts. So what does that mean? If you look at our K value, we do not switch the sign. It's just whatever it is in the equation, it's the same here. So our K value is 1. All right. So that means we are going to move. Since it's positive 1, we're going to move up 1 space. All right, so if you think about it, h value moved us back 5, and now we're going to move from here up 1. Okay, up 1 from here. Boom, up 1, and this is going to be my new dot. So I can now erase this. So if you think about it, we shifted left 5 and then up once from our original vertex. So left 5 and then we went up 1. Okay? So from our original vertex to our new vertex. Okay, so now we know from a previous week that our axis of symmetry always goes through my vertex. So I'm going to put a vertical line here. This is the axis of symmetry. Okay, that means we have to match a dot on the left side with a dot on the right side. Okay, and the way we're going to do this is what we call the 1, 3, 5 pattern. So to get the other dots, we're going to use what is the 1, 3, 5 pattern. Okay, to use this, we want to take our A value and multiply our A value here, always with 1, 3, 5. So our A value is 1. If I multiply that in, we still get 1. So what does that mean? So it says, the 1, 3, 5 pattern says go right 1, and then this guy, these numbers here, tell you how to move up or down, depending on sign. Since it's positive, we're going to move up 1. So over 1, up 1. Okay? Now, from this next number tells you how to move from this new dot. So let's multiply with the A value. What's 1 times 3? It's still 3. So that means we're going to move from our next dot up 3. So from here, over 1 again, and now we're moving up 3. 1, 2, 3, and there's our new dot. Okay, we have one more movement, so let's multiply here. The A value times 5. That means over 1, up 5. Okay, so if you look, over 1, up 5. 1, 2, 3, 4, 5. So we're way up here. Okay, so again, this is our new parabola. We got the right side done. Now we just copy everything to the left side. Copy, 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 and this is our new parabola. Okay, again, this is the 1, 3, 5. This is how we get our other 3 dots on the right side. We're always going to go from our vertex over 1, and then these numbers tell us how to go up or down. So we went for the first number 1, we went over 1, up 1. All right, so I'm going to put that in so just so you guys can see, because this is how we're going to graph. So we went over 1, up 1, over 1 again, up 3. Okay, over 1 again, so over 1 again, and then we went up 5. So it was the 1, 3, 5 pattern, and this is now our graph, and then we just copy it over the axis of symmetry. So if you look, our vertex here is 1, 2, 3, 4, negative 5, comma 1. And one thing I want you to notice, negative 5, that was our H value, and 1 was our K value. So if you think about it, our vertex, this is why it's called vertex form, is simply what is your true H value and what is your K value. And that's how you can always find the vertex. So to summarize, this was our original graph. This is always your original graph. How did it change? It didn't get skinnier, or it did not get wider. It did not flip upside down, because the A value is 1, nothing happens. But it shifted. It shifted to the left 5 and up 1. So this is my new vertex, which is negative 5, 1, HK. Negative 5, 1. And then we get our other points by doing the 1, 3, 5 pattern, but you always have to multiply by your A value. So it starts off at 1, 3, 5 pattern, but then we multiply by our A value. Okay? All right, so standard form. Let's go ahead and check out standard form. So how do I put something in standard form from the vertex form? So let me write that. So now we're going to do the standard form. And that's pretty easy. We're just going to go ahead and do all the math here. We're going to multiply to the power of 2 of our vertex form. So it looks like this. So our original is x plus 5 squared plus 1. Okay, and now we just want to multiply that out. So x plus 5 squared really is x plus 5 times x plus 5, and then we got the positive 1 at the end. So we're going to distribute the x, that's x squared, plus 5x. Distribute the 5, that's positive 5x, plus 25. 5 times 5 is 25. Bring down the positive 1, okay? And now we have combined like terms. So we have 5x plus 5x. These are like terms. So we have x squared plus 10x. All right, and then 25 plus 1 is like terms. They're both constants. That's plus 26. And that is our standard form. Okay? Last thing they asked us to do is find the y-intercept. Okay, so this should not be new. We did this last time. How do I find the y-intercept? If you recall, the thing we're going to do is plug in x equal to 0 in standard form. Okay, so this is from last time. 0 squared is 0. 10 times 0 is all this is 0, because when we plug in 0, it turns into 0. So when you have it in standard form, your y-intercept is always your c value. Only in standard form. So if you look at it, if you wanted to try plugging in, 0 squared is 0, 10 times 0 is 0. So what's 0 plus 0? 0. 0 plus 26 is 26. So that means my y-intercept will always be my c value. So the y-intercept is going to be 0, comma, 26. And if you remember, we have to write it in point form. That means our x is going to be 0. So here's x and your y. Your y value in the y-intercept will always be your c. Okay, this will always be your c value when you're finding the y-intercept. Okay, there we go. Let's do number 4. We're just going to graph it. Okay, so standard form, y-intercept. My goal right here is just to graph. All right, so I can show you how this works. So let's go again and let's find the a value. Our a value is here. Okay, it's actually -1. Okay, our h value is here, but remember opposite sign, so that's going to be +1. And our k value is here. We got our a, h, and k. So how does this affect my original graph? Okay, so since the a value is -1, it does a couple things. So what does it do? Because it's negative, we know it's going to open down. So it opens down. So it's going to have this shape. Okay. Is it wider or smaller? So ignoring the sign here, we just look at the number. Ignore this sign. Look at the number. Is the 1 bigger than 1? No. Is the 1 less than 1 or smaller than 1? And the answer is no. So that means it's not going to get skinnier or wider from my original. Okay, so the only thing the a value tells us right now, it opens down. What does the h value tell us? Since it's +1, that means we're going to shift to the right 1 time. Okay. Our k value controls up and down shift. That means we're going to shift our vertex up 5 times. All right. So let me get my original down. We'll put that in orange again. So again, your original, this is your vertex. It always starts at 0, 0. We're going to do the over 1, the 1, 3, 5 pattern. So again, follow along. The 1, 3, 5 pattern says go over 1. Here's your 1, 1, up 1. Go over 1 again, but now we're going to go up 3. Here's the 3 part. Go over 1 again, and we're going to go up 5. The 1, 1, 3, and now 5. 1, 2, 3. Sorry, let's do it again. Over 1, 1, 2, 3, 4, 5. Now copy them over the axis of symmetry. This is our axis of symmetry for the original. Okay. So I'm not going to connect it. Just understand these are this is the original dot. This equation has now changed it to do all this stuff to it. Okay. So just like before, the first thing we want to start to do is let's shift. Okay. I had mentioned before, your new vertex is just your h and k. So my vertex now for my new graph is whatever your h is. Your h goes here, your k goes here. So my vertex for my new graph is going to be 1, 5. And I got that from h and k, 1, 5. So let's plot that. over 1, up 5. 1, 2, 3, 4, 5. Here's my new vertex. And if you think about it, I did a shift over, just like I said I would. Over 1 shift, and then up 5 shifts. And I got my new vertex here. Okay? So this is my vertex. We now know that my vertex has an axis of symmetry. So your vertex is always your axis of symmetry line as well. Okay. So let me label. This is my vertex. And it's 1, 5, HK. All right. Now from our vertex, we want to get our other dots that we had like in orange, okay? All right, so we got to now use the 1, 3, 5 pattern. So 1, 3, 5. But we want to multiply these numbers. Remember, these tell us that when we go over 1, we're going to go up 1. Over another one, up 3. Over another one, up 5. But before we do that, we always want to multiply by our A value. So what's our A value? Our A value is -1. So we're going to put -1 right here. Okay? So our A value, and now we're going to multiply that in to get our true pattern. So -1 times 1, that's -1. -1 times 3, -3, -1 times 5, -5. All right? So how do we use this? So from our vertex, we're going to go right 1, and this now tells us we're going to go down 1. So watch. Right 1, down 1. Okay, so that's where my second dot goes. Okay, now from my second dot, we're going to go right 1 again, always to the right once. But now it says we're going to go down 3. So this tells us our next pattern says right 1, down 3. 1, 2, 3, and put a dot right there. Okay, now from that dot, we're going to go always right 1, and now we're going to go down 5. Right 1, down 5. 1, 2, 3, 4, 5. And that is our final dot. And this is how we use the 1, 3, 5 pattern. It's affected by our A value. We'll multiply that in. If it's negative, we're moving down that many jumps. Okay? So if you look, we now have the right side. Now we just copy it over our axis of symmetry. So it's here, here, and there, and this is our parabola. Okay, so again, very important that you know this stuff here, and then how to use the 1, 3, 5 pattern. Okay. All right, so we'll get you the checkout code and get you out of here.